I'm Tom Hund. Thank you, Stuart. I am faculty in biomedical engineering. My lab is in the Davis Heart Lung Research Institute. I've been here since 2011. I also serve as associate director of the DHLRI. I've served ad hoc on several NIH study sections for training type grants. And then as of last October, I'm a permanent member of a standing study section at NIH for the electrical signaling, ion transport, and arrhythmia study section. So that's my background.
I'm John Christman, so I'm a simple critical care doctor. So I went to, let me give you a little bit of background because it's quite a bit different than Tom's, who's a very polished scientist. So I went to medical school at Indiana University where I graduated, and then I trained at the University of Vermont in chest medicine and Pittsburgh in critical care. So I've been an ICU doctor for my entire career, which is now 40 years since I graduated from medical school. I've been on the faculty at the University of Vermont and had leadership positions at all the places I've been, at Vanderbilt, UAC, and OSU. And among that, I was at least part-time supported by the VA for 25 years. So I actually have been funded, surprisingly, individually since 1988 by either the Department of Veterans Affairs or the NIH or both, and have about 160 papers. So I haven't really ever had a gigantic lab, but I added this up, and I've had about in the low 20s in terms of millions of dollars of taxpayers' money. So I'm not sure whether or not people think they've gotten a good deal out of that or not. But I really pride myself on being a mentor, and some of my mentees have been extraordinarily successful, and I'm really very proud of them. I have been on a lot of study sections. I was a permanent member of surgery, anesthesia, and trauma, and since I'm a internist, I was the only internist on it, so you can imagine how long the surgeons had to vet me before I actually went on the study section. But I've also reviewed for LIRR, LCMI, SBIRs, the T32s, the K Awards for Heart, Lung, and Blood, Italian Cystic Fibrosis Foundation, the Austrian and the Bavarian Science Foundation, and really a lot. I really wanted to learn how to write grants, so I decided I was going to sit on study sections, and it was really difficult at first, I'll just say that, and I made a lot of gaffes. I also was an editor associate editor for 12 years for the American Journal of what's called the Red Journal, or the clinicians call it the Unread Journal, in pulmonary medicine, but also the Blue Journal, which is the best journal they have, and AJP Lung. So it's kind of a long story. So here, I'm a mentor for Josh Englert. Who knows Josh? He's a K awardee. And John Whistler, who's a surgeon who just put a K in. It was going to be reviewed this week. Hopefully that'll go over really well. And my lab's also in the Davis Heart and Lung Research. So I know that's a little long-winded, but I thought I would go through it so that those here with just an MD have some hope. So, all right.
Yeah, so we thought, so I'll give some kind of tidbits, and then John will add his advice, and then we'll take questions. So actually, this is well timed because my critiques for ESTA are due at 10. So I'm going to leave from here and upload my final comments on grants that have been submitted, mostly R01 applications. And so I'm in the midst of it, so I can tell you sort of the process that I go through when I review a grant, what kinds of things I'm looking for, what are some red flags. And this will be tailored mostly towards R01s, but there are universal themes across funding mechanisms. And so when I'm assigned an application, the very first page I go to, regardless of opportunity, whether it's a early career or an R01, I always go to the Biosketch, right? So if if you haven't done the hard work leading up to the application, if you haven't gotten the papers, if you haven't, built that foundation, no matter what's in the rest of the application, you're already at a disadvantage. So hopefully, by the time you've submitted your application, you've already done the hard work, which is, doing the science, getting the papers, getting the training that you need, forming collaborations. But that's always the first thing I look at is the Biosketch. And so what I would say about the Biosketch is, obviously you have to do the work, you got to get the papers, you've got to get the training. But the Biosketch, there's lots of opportunity to shape the narrative. So one thing I always tell early career people is the reviewers are going to be creating a narrative around you, and you want that narrative to result in them saying, this is a person we want to invest in. This is a person who's going to do great things with the money that we give to them. And so you play an active role in shaping that narrative. Don't let the reviewers create the narrative. You create the narrative for the reviewers, and you do that in the Biosketch. You're supposed to list your contributions to science. Take that seriously. And the whole time, be thinking you want to create a narrative that, where you have this trajectory like this, and if they give you money, it's just gonna shoot up. And so that's one thing. I think that's a really, really important thing to keep in mind is that the reviewers are going to be creating a narrative. So don't, make it easy for them to create a story about you that's positive. Things like, if there's gaps, if there's, gaps in your training, if there's a, kind of a detour, I always say, address that head on. Don't run from it, because if you don't address that gap or that detour, they're going to create their own explanation, and it's not going to be favorable. So, address. Don't try to brush things under the carpet. If you've had, we've all had detours. We've all, things rarely go just as you plan them. So just tackle it head on and weave it into your narrative. The second page I go to then is the Ames page, and I always tell my trainees and people, spend a lot of time on that Ames page, because the people assigned to your grant will read the whole grant cover to cover, but everybody else in the study section, you'll be lucky if the other 6, 7, 8 people read your application. They're going to be reading that Ames page while the discussion's going on. The other thing is your reviewers, even the reviewers that are assigned to your application, are going to be reviewing your application at the worst possible time, right? They're not going to be reviewing it first thing in the morning when they're alert and have 100% brain function. They're going to be reviewing it at the end of the day. The kids are, they're running around. They're still active. You've got to deal with them. You got to deal. They're going to be doing it in between their normal responsibilities and not at their peak function. So you really have to have empathy for the reviewer, and don't assume, don't assume that whoever's reviewing your application is going to have the same background that you do. A lot of times as a reviewer, you get assigned applications that are kind of within your general circle of expertise, but rarely do you get an application that's like a perfect alignment with what you're doing. And so, don't overassume the background for your reviewer. It's always better to assume less than more of your reviewer. And use, at that Ames page, be real careful to just, take them by the hand. That's how I always picture it, is I have the reviewer by the hand and I'm walking them through my brilliant idea, step by step, starting with the big question and then working to how the specific experiments or studies I'm proposing in my grant are going to answer that question. I spend much time on the Ames pages that I write for my grants for that very reason, and it should be so that a kind of a science person that's not in your general area should be able to read your Ames page and kind of get excited. And the other thing I always say about the Ames page is that for a reviewer, enthusiasm is at a peak at the end of the Ames page. It's only going to diminish once they get into the research plan and they get into the nitty-gritty and they start picking apart what you're proposing to do, it's real easy to find flaws in a research plan, right? I mean, so if you really want the enthusiasm for the reviewer to be at a max, really high, by the time they get to their aims page, because it's just going to drop as they start picking apart the nitty-gritty of your research or your training plan. And then obviously you get into the research plan and the details of the proposal. You know, with the research plan, my approach is, you know, the reviewers are going to be trying to poke holes, right, in your plan. They're going to be looking for things that don't line up, experiments that don't quite test the hypothesis, data that are uninterpretable. So they're going to be kind of cranking through your research plan and just looking for cracks. And so the more you spend thinking about your experiments, you know, the more you think about your plan, the more you can identify the cracks before the reviewers do, and then you can account for those potential flaws in your alternative approach or in redesigning your study. But really, when you put together your research plan, your goal should be, you don't want the reviewer to think of something that you haven't already thought of, right? You're going to spend much more time thinking about this plan. Same for the training plan, if it's more of a career development thing. You don't want the reviewer to have thought of something that you haven't thought of. And you know, you can think of a weakness, a potential flaw. It doesn't mean you have to have an answer for everything, but you should, you know, there should be a contingency. There should be some indication that you've thought of that as a potential problem, and that you have a plan if things don't work out. And so I make heavy use of my potential pitfalls, alternative approaches, that paragraph. I put a lot of stuff in there, and I like to, I read that carefully and look to see that the applicant has been critical in how they're thinking about their plan and do have, you know, alternative directions if something doesn't go exactly how they expected. Yeah, so I'll leave it there. You can go ahead and add your thoughts.
Okay, I just want to go over a few things a little bit. First of all, this first thing's a little controversy that I'm going to say. I think everybody knows if you're a scientist or not. And I believe that scientists are born, and it's a mixture of nature and nurture. But pretty much by the time you're 10 years old, I think you know if you're going to be a scientist or not. And then the process actually polishes that. And grants is an acquired skill. Writing a good grant is an acquired skill, which means you need a lot of practice with it. It is very clear, and I think Dr. Happ also mentioned this, that getting small grants predicts success. So like in my field, the American Lung Association has a small grant. The American Thoracic Society has a number of small grants that are available that are highly prestigious. I'm on the finance committee, and these are so important. We just doubled them. We've invested, and now we've obligated future finance committees to paying for these for the next 5 to 10 years. So these small grants are really worth your time for two reasons. One, you sort of get the science logic together, and two, you get a review back, and that each review that you get will make your next grant stronger. I think it's very important to remember that the currency of academia is data, and data doesn't exist until it's published. So it's very important to have high quality science and to have publications and a track record. Clinical research, if you're trying to get a K award or whatever, it's very important that you have established that you can be a strong member of a team, because even though academia is a meritocracy, meaning we all get credit for being the principal investigator, science is really better as a team science. So you have to really have a strong team. I think the biggest mistake I see, and I've worked with a lot of both PhD and MD junior faculty that have been trying to get their first grants, is starting way too late. I mean, you can put this off to the last minute, and by God, you're going to get it done. And my son is a geographer. He's been known to submit a grant starting at about 5 minutes to 12 p.m. and then putting in 5 or 6 different versions of it before the deadline at midnight. So waiting to the last minute really isn't a good thing, really. In fact, starting early is really important. As Tom says, the most important page is your specific aim page. I'm currently writing a grant. I spent an entire month on the first page because once you finish that first page, it locks you into the rest of the grant. It's got to be consistent with that first page. Now, you can go back and modify that first page a little bit, but realistically, if you don't have that, you don't have a plan for your entire grant. So that's a really important thing. And I would say once you've got what you think is a good first page with a logical hypothesis and with, I think it's better to have 2 than 3 specific aims just because of the 12-page limit on a R01. Once you have those specific aims that support the hypothesis in a non-overlapping way, then I think it's a good idea to send that to your program officer. You need to be friends with your program officer. These are very smart people that have seen an awful lot of grants, and they can actually help you promote your career. For instance, let's say you get a score and it's not quite fundable, even with early stage investigator advantage. They can when September comes, if there's money left over, you might get an R56, which is 1 year of full funding that'll help you get that R01 next time. So program officers are really good, but you've got to have something to show them. Having a few publications in good journals. So I think who wants, anybody here have a Cell paper or a Science paper, or a Nature paper, or whatever? Good, because now we know that if you publish in those, that only about 10% of the data is ever reproducible, right? Yeah, I think everybody knows that. I had a conversation last night that was led sort of by Rama Malapalli at dinner. We had a visiting professor coming today, and he points out that it's the journals, the strong journals are often not the highest impact journals. Like he was touting that JBC, it's nice to have a couple of JBC papers. It doesn't have a real high impact, but the review process is very rigorous, and the real science is published in JBC, or Journal of Immunology is another one. Or in my field, that unread journal actually is very well reviewed, and the science that's there has a real live publicity in the area of lung sciences. So I think that's a really important thing. But I think one of the biggest problems with young investigators, they don't have enough publications. You need a few, 4 or 6. It depends on your level. But the longer you go in your field, the more that's expected of you. And I think a lot of us, and I was guilty of this for sure, want to publish a magnum opus. We want something that's wonderful and splashes in science. But you're at jeopardy of being a one-song hit or and never publishing anything else, because it takes so long to get a publication like that. Usually it takes in the range of several $100,000 worth of material to get a science paper. But a red journal paper is very good, and if you've got several of those at a first author level and some middle author papers, that'll really put you in good stead. So first author means that you did most of the work. Co-first authors, sometimes you have to share things depending on your situation in your lab. That should have equal significance, although single first authors have more significance. You need to kind of remember that in some ways. But middle author papers are very important too, because it implies that you're good at networking and at working in team science. So the last thing I wanted to say, just very briefly, is some of the things I look for when I review a grant, and Tom went through it nicely in a sequential ways, but I like to look at scientific logic. You know, there are, you know, in fourth grade you learned about the scientific method, and that applies to clinical translational as well as basic translational. You want to look at the quality of the data, how reproducible it is, what the ends are, things like that. Don't leave that off of the supportive data that you have. Clarity and consistency through the grant is really important. Controls. If you can only do one experiment, just do the controls. If you don't have enough, do the experimental group, because we want to know what the controls are that you're using. And if you don't list your controls and really are careful in how you control an experiment, then the science will be of no value. The power in statistics. It's often good to elicit a statistician to help with that. Even if you're just doing basic science with Western blots and stuff like that, you still need a statistician. Feasibility is important. And then the most important thing, and I'll just emphasize what Tom said, and that is you have to know what the limitations of your data are, and you have to have an alternate plan. I usually try, when I write it, to think of the most obvious thing and then address it. Leave it out of the series of approach, and then address it as a potential problem. So I like to put that right out there so that the reviewers will pick up on it, I realize there's something missing, but I know how to address it.